So if you own a laser engraver, you know that they make a lot of smoke. Some higher end diode and CO2 lasers do come with enclosures, but what I've got is not one of those. What I have is an open gantry style diode laser, and it's kind of a basic entry level thing that a lot of hobbyists use. You can purchase enclosures for diode lasers, but I wanted to make my own. I don't use my laser for a lot, but what I do use it for mostly is cutting templates like this one here. As you can see in this shot, there's a lot of smoke, and what you're not seeing is there's a big fan outside the camera range behind me, and it's blowing all that smoke out the open window. And in the winter, that gets cold. Now, one of the things I don't like about most of the laser enclosures you can buy is they all lack certain features, and for mine, I wanted to add a few. This template right here that I just cut, and the hole that I'm putting in this piece of plywood right now, is going to be for a fire access door. So I got this idea from my days as an aircraft mechanic. Some of the jets I worked on had engine compartments or auxiliary power unit compartments that would have these little fire access panels. So the idea was, if there was a ground fire on, say, an auxiliary power unit that was accessible, you could jam the end of the fire extinguisher nozzle into it and discharge all the halon inside, flooding the compartment without letting it go all out into the atmosphere and not extinguish the fire. So I'm making a little spring-loaded access door that'll be on the side of the enclosure. Should the laser start a fire on whatever material I'm working on, instead of having to get dry chemical fire extinguisher stuff all over my shop, I can jam it into this panel and flood the compartment, contain the fire, and all the dry chemical. Is this necessary? No, it is not. Do I think it's cool? Yes, I do. And there are a lot of features that are going to be in this build that aren't necessary, but I think are cool. So, as you watch this video, you're going to notice some continuity errors, and that's because I tried to edit together to kind of keep all the elements that go together so it makes some level of sense, but you might at times see things that are done in earlier shots that then I'll show how I did them in later shots. Anyway, what I'm doing right now is adding holes for the air intakes. For the exhaust system to be effective, I have to suck a lot of air through the enclosure, and to have air moving through, it has to enter just as much as it has to leave. Another feature that this enclosure is going to have is LED lights, so it's really well lit to be able to see the workpiece. Now this is definitely on the overkill side of things, but rather than just stick the LEDs to the side of the enclosure, I made this little triangle shaped piece so they would shine down onto the engraving bed. I put lights on both sides and the back panel of the enclosure, and as you'll see later on, they'll do a really good job. Right here I'm adding spring-loaded hinges for that fire access door, and I had to add those beef ups because the screws were too long. I made the entire enclosure out of 1/2 inch thick birch veneered plywood. I always planned on painting it, so I wasn't too concerned about things like nail holes. All these and the seams I ended up filling with Bondo and smoothing before I did the paint to get the nicest finish I could. All the joints are glued, but I also used the nails so I didn't have to sit and wait for the joints to dry. This project went pretty quick. I finished it start to finish in 3 weeks. The bottom of the enclosure has a large hole where my honeycomb cutting bed will sit. The reason I didn't make the bottom solid will become more apparent later on in the video, but for now I'll tell you that the current diode laser I have is not actually tall enough to clear that honeycomb cutting panel. The panel's just a little bit bigger than what my laser can fit, so by lowering it 1/2 inch into the enclosure, it clears perfectly. I probably should have done this before I glued all the pieces together, but I still needed to add holes for the cords to go to the laser, a slot for the air assist tube, and 2 giant cutouts for the exhaust ducts. As an example of the usefulness of having a diode laser that can cut through 1/4 inch plywood, every single cutout that went into this enclosure was done with a laser cut template. So it's not really all that difficult to make a functional laser enclosure. I mean, after all, it's just a box with a fan coming out of it, but I wanted mine to look cool. Of course, coolness aside, it's also important that it's functional, and to that end, I had to add 2 windows into the lid. The lid has to be in 2 pieces and has kind of a hinge scissor effect to it to be able to fully open it up and access the cutting panel without having too much trouble. It also needs to have a big giant window in the top so that when I want to use my camera system for it, I can. I'm not going to get exactly into what a camera system is for on a laser right now, but if you want to see my video about it, click the link in the upper right hand corner. Anyway, what I'm doing right now is cutting a hole in the top section of the lid that will have a clear plexiglass panel in it, and I'm going to route in a little rabbet so I can glue that panel in from the bottom. The reason I didn't just put the camera inside the enclosure is that it has to be a certain height above the cutting bed for proper calibration, and I didn't want to make this thing 2 feet tall. For the angled door, I set my table saw blade to 67.5 degrees to make 2 sides of the complementary angles. This door was one of the more complicated parts of this project to make. Now, obviously I'm going out of my way to make this more challenging and complicated than it needs to be, but again, I wanted this to look cool. I probably should have mentioned this earlier, but I basically made this entire design up as I went along. There wasn't a whole lot of pre-planning. So with that being said, certain steps had a little bit of material waste, as you'll see on this one. I probably could have saved a fairly large chunk of plywood if I had cut the 2 sides of the middle part of this door separately instead of having it as one big piece. But this did work. Just the same as the top part of the lid, after I removed the excess with a flesh cut bit, I used the router to cut a little rabbet to hold my plexiglass panel that I still had to make. I used the smallest size dominoes to be able to secure that 22.5 degree angle that helps make up the shape of this lid, and doing that with 1/2 inch plywood is tricky at best. After putting the little dominoes in and gluing all the joints together, I clamp/taped the entire thing together to hold it and then let it dry in situ so it would maintain the proper shape. Even so, I was kind of worried about these joints, so I added these beef up panels on the back using some scrap oak. And some nails, kind of a lot of nails. It would have been easier to do this before I glued the lid together, but I did go back and square up the corners of the rabbet where the plexiglass panel will get glued in. So you can hurt your eyes with the glare from a diode laser, and what I have to help filter that is this piece of orange welding plexiglass that is used for welding enclosures. I have it left over from when I built mine a few years ago. Of course, for coolness factor, I had to bend it to fit into my lid. After I got the dimensions figured out with that cardboard template you saw earlier, I made this little form to bend it around and then just used a heat gun. This was surprisingly simple and easy to do. Each side took probably less than 3 minutes to bend. I only had this one scrap of the welding plexiglass to use, and luckily I got it right the first try. And I didn't film cutting it out because compared to bending the orange one it would have been boring, but here's the clear one. I filled in all my seams and nail holes and some of the raw plywood edges where there was voids with Bondo. Now, due to a major oversight on my part, I forgot about filming any more of the lid pieces as I finished them, but here they are, fully painted and having the plexiglass glued in with silicone RTV. I went with black on the outside and then a gloss white on the inside. I went with white so I could tell if soot started to build up that maybe my exhaust system isn't as effective as I want it to be. The base is just made out of construction grade dimensional lumber. I did fully remill it so I'd have nice consistent pieces. All the joints on the framework of the base are just dominoed together. Now, there was a time in the design phase, in my mind at least, where I thought I might want to put drawers inside this thing, so I made a very large base with the idea that ballast would go into it so the cart wouldn't tip over if the drawer was opened. I did end up still using the ballast compartment, but I abandoned the idea of drawers when I realized how big the exhaust system was going to be. The top piece of the base needed to be sized so that it would be big enough for the enclosure to sit upon, but still have the hole for the recess for the cutting panel. If it's not making sense to you just yet, I promise it will by the end of the video. So the base is really just a rolling cart made of two compartments. The upper compartment will have a shelf that I just put in the supports for. This is for a lift mechanism as well as the exhaust ducts, not the exhaust fans, all the electrical, and the air assist pump. The bottom part of the rolling cabinet has the ballast compartment as well as the exhaust fans and then storage for random laser stuff. Right here you can see I'm putting in the ballast compartment. At this point I had already abandoned the idea of having drawers that would require ballast so the cart didn't tip over, but I thought extra mass is never a bad thing. I also added lockable casters to the bottom so I could move the cart around easily. I prefer to run my laser off Lightburn, so I have a shop laptop that I use. I made a little folding table that sticks to the side of the cart so I could put it up when I wanted to use the laptop and the laser and then fold it down when this thing is in storage. This cart ended up being pretty large, but being able to have the table fold down from the side kept it to a size that I can easily get out of my way when I want to. Now, right now, I'm making the support that's going to hold that table up, and adding these cutouts into it was way more over the top than was necessary, but at this point, I had really gone all in on the cool factor. I forgot to hit the record button, so you didn't miss anything, but I cut those slots out with the jigsaw, and then, as you can see, cleaning everything up with files and the spindle sander. Adding those triangular cutouts probably only added about a half hour to the entire build process, so it wasn't that much wasted time. And here you can see how these pieces work together with them fully installed. I got a little lazy on the cabinet doors. They're just a piece of plywood with trim glued around it to make it look like an actual floating panel. As cool as I want this thing to look, ultimately it is still a piece of shop equipment. The two doors open up on the bottom to access the lower compartment, and the top part has this drop down to be able to get at everything. And there you can get the first peek at the lift mechanism. I decided it'd probably be a good idea to add some sort of handle to this, so I cut out these little brackets from some 3/4 inch plywood. I did a really nice job on one and then used it as a template to make another. These two have holes drilled through them that will eventually hold a rod. These two pieces then got glued and nailed to other pieces and ran through the router table again. I used a piece of leftover closet rod from another project to make the rest of the handle. Diode lasers really only have about an inch of travel on the Z-axis, so if you want to be able to engrave something bigger, you have to prop it up on legs, kind of like you can see on my laser in the background there. Since the laser is going to be encased inside the enclosure, if I want to be able to engrave something taller or use the rotary attachments, I need to be able to move the cutting surface down. I could have made a scissor lift, but I bought this Lab scissor lift jack stand on Amazon for less than $40. I'll put links to this and some of the other parts that I used on this build in the description of this video. Other than adding holes for these screws so I could attach this piece of plywood to it, I didn't have to do any modification to the scissor lift. The exhaust system starts as two intakes on either side of the laser within the enclosure. They go down into these two ducts that I'm assembling here. To give space consideration to the lift, I had to make these pretty narrow. They go on either side of the lift mechanism, and then at the bottom will widen into 4-inch holes. I cut those holes on the drill press with a hole saw. Here you can see the ducts in relation to the lift mechanism, and then I filled in that gap with these little 3D printed fairings. On the bottom side of the shelf, I realized I had to remove a little bit of the support bracket so I'd have room for the next part of the exhaust system. This wasn't difficult as I didn't have the shelf glued in yet. Adding this cutout gives me the space to be able to use this little 3D printed flange as part of the ductwork. I designed and 3D printed almost 50 different parts for this entire project. These two scrap wood standoffs I'm adding are to create attachment points for the exhaust fans. Originally I was just going to use one fan, but then I thought, why use one when you have room for two? I made this little manifold and these boots on the 3D printer as well, and then attached it all together as you'll see. The accordion tubing is just left over from my dust collector system. I primed and painted using a roller and brush. The base was done with hammer metal, and then I also used clear polyurethane on the other panels. The first assembly step was putting the wheels on permanently. Next, I glued and nailed on the lower back panel so I could finish the exhaust system. Construction adhesive probably would have been better than the wood glue since I had painted all those edges, but it's what I had on hand, and I think it'll be fine. After I put in the middle shelf, I added another flange for the exhaust on the inside of the back panel. This is what the little exhaust manifold attaches to, and then everything branches off from there. As much as I like a laser engraver and cutting machine, I don't think there's anything more useful for the shop than having a 3D printer and knowing how to use it. The outside of the back panel gets one more flange for the exhaust. This will be for a removable hose to attach to. I put a little weather stripping for the top of the exhaust ducts because the enclosure itself is only going to be screwed onto the base and not glued. The bottoms, though, did get sealant. Then I glued the ducts into the framework. With the plywood exhaust ducts installed, I was able to add the last piece to the puzzle. Next, I started figuring out LED strip lighting for the interior of the enclosure. I'm not going to get real in-depth on how to do this because I've done several videos involving LED strip lighting before, and those are much better resources than what I'm showing right now. I'll put links to those videos in the description if you're interested, or you can just look through my film history. That black tubing that the wiring is going through is just drip irrigation line. Because I put the lights in on an angle on these little triangle brackets, I had to use these tiny little sections of wire to make the corners. Unfortunately, it was really hard to film it because my hands were always in the way. The last thing I did was solder a female receptacle to the power lines and then put heat shrink over that. And they work. Then I put the fire access door on for the last time before putting the enclosure onto the base. I needed to add a little bit of a cutout into the base to make room for that light wire that comes out of the bottom of the enclosure, and it was pretty simple to do. The enclosure is just held onto the base with 4 screws because I figured if I ever need to remove it to do any kind of maintenance or modifications, I wanted to make it easy. Next, I installed all the louvers and fair leads that I had 3D printed into the top of the enclosure to finish it off. I didn't want to permanently install the lift mechanism, so I made these little angle corners that would keep it properly aligned, but still allow me to fully remove it quite easily. I didn't film the installation of all the electrical on the inside because it was very tedious and having the camera in the way was starting to bother me, but here's an overview. Power enters the cart, comes up here to this junction box, gets from the braided wire connected to hard wire, and this line comes off and goes up to the master switch. Power goes out to that junction box and then splits to 4 different outlets. Each outlet has power coming in, leading off to the switch, then back in. This one back here is for the fans. Line comes up through that hole. And all controlled by the master switch plate. Alright, so let's talk about that switch box. It's 3D printed with white resin in the letters. Making it could have been a video of its own. Is it necessary? No. Once the exhaust and electricals were all done, I was able to finish installing the side panels. Next came the doors on the front of the base. I needed a 2-way hinge for the middle part of the lid, so I 3D printed one. Because of the size of my print bed, I had to make it in 6 sections. I wanted the front of the lid to be able to open upward as well as fold in on itself. Here you can see the different ways that the lid can open. I trimmed the top of the laptop shelf with this piece of automotive upholstery leather that I had. I did this because I wanted the top of the shelf to not be too slippery so the laptop wouldn't slide off. Next, I installed the fixed mount for the camera armature. I rarely actually use the camera, so I wanted to be able to move it out of the way easily. When I am using the camera, I can only open the orange part of the lid because otherwise it'll hit the camera itself, so I had to make this little lid stay to hold it up. This was the last 3D printed part that I made for this project. Oh, and incidentally, camera calibration did work through the window. This is also the ultimate dork move, but I made this little sticker on my vinyl cutter for the fire access door. The final step of this build was putting the bricks in the ballast compartment. It probably could have held a few more, but I only felt like cleaning up 10. I started testing by connecting the removable exhaust duct and running it out the window. The first thing that I wanted to check was to see how much air the fans would move through the enclosure. There was a lot of suction at the 2 exhaust intakes. That was all well and good, but I had to make sure the airflow through the enclosure while the lid was down would work, and it did. With that looking good, I put the laser in and connected all the cords. Everything fit in the lower compartment, though it did fill up more than I had expected. I ran a few framing tests to make sure there was enough room for the cords and the air assist tube. Luckily, that all looked good. Next, I tested the full travel of the lift with all the stuff installed in the lower cabinet. Here you can see you really only get about an inch of adjustment on the Z-axis with the cutting surface at its full height. Since I can lower the cutting surface, when I want to use the rotary engraver, all I have to do is this. If you're interested in seeing more about the rotary engraver, click the link in the upper right hand corner. Now it was time to make some smoke. I threw together a random little cutting test. I didn't actually make the power as high as I ought to have to be able to cut fully through, but my goal was to make smoke, not cut holes in this wood. The exhaust system worked exactly as I hoped it would. Next, I ran the test again, only with those blocks set to fill so I could really generate some smoke. It's hard to see on film, but the airflow moving through the enclosure really pulled the smoke out well. Even with the cutting surface lowered, the smoke extraction still worked perfectly. So there you have it. I would say that this entire thing functioned exactly as I wanted it to, so it was a success. And aside from just being functional, I think it looks nice, and I'm going to be happy to have it in my new shop when that's built in a few months. And I haven't really gotten into the ultimate reason why I did this. Now my workbench is completely clear of the laser and I can use it for what it's intended for. And when not in use, the laser can live here. And as always, if you made it this far, thanks for watching.